Hello and welcome in this introduction to complex numbers. In this video we are going to see why we need to extend the number system that you have used so far and also how we are going to do it. To begin, let's imagine this situation. You are in primary school and you have this problem to solve. You had 8 apples in the beginning of the day. Now you only have 5 apples and the teacher asks you how many apples have been added during the day. Well, no matter how long you have been thinking about this, you just can't seem to find the answer. How many apples have been added? Well, this problem simply does not have any solution among the number that you already know, which in primary school most probably are just the natural number. So here we are going to say that there is no solution among natural numbers. I have denoted natural numbers like this, but don't worry, we are going to come back to that. Here the most important is just to realize that it's not a matter of how intelligent you was back then, it's just that you didn't knew about negative numbers, and since you had not enough numbers in your number system, you just could not find any solution. Now the years have passed, and in the meantime most probably you heard about negative numbers, so you can find solutions to that. Now most probably you are finishing high school, maybe you are starting uni, and still, are you sure that your number system that you know is big enough in order to solve any solution? Well, try to answer that. What possible number can I put here that will make my equation work? Well, let's think a little bit about that. Because no positive number seems to work. Okay, if I square any positive number, I cannot have a negative number. Problem is that if I square a negative number, I still can't have a negative number at the end. No fractions seems to work here. No irrational number. I mean, pi is not a solution. Square root of 2 is not a solution. So what can I do here? Okay, you can maybe pause the video and take a moment to think about that, but you will quickly realize that there is no solutions among the numbers that you already know. By the way, so far, all the numbers that you have worked with are called real number. And there is no real number that can be the solution of this equation. Okay? In other words, what we will need is new numbers. Okay? Just as when you are a kid and you realize that you can add more apple to your set of apple, but you can also lose apple, and so that you need negative numbers. Okay, before going a little bit more in depth about the numbers that you already know and the different sets of numbers, I just want you to realize, maybe you are thinking, at the end, here it's quite obvious why I needed an answer to that. But in what scenario can I possibly need an answer to that? And very quickly we will come back to that, but I just wanted to tell you that currently you are watching my video, and thank you for that. You are using an electronic device to do that. And without the complex number, okay, you could not watch my video. So let's be grateful to the mathematicians that came up with these new numbers, and let's take a step back to clarify what are the different numbers that I already know, what is a set of number, and what is the new set of number that I'm going to work with. First of all, what we call a set in math is just a collection of elements. It's like, for example, I have a little set here, and I will put in it the number 3, a cloud, a heart, and a little smile. Okay, this is a set. Okay, here we are only going to talk about sets of numbers, so unfortunately, no smile, no heart, and no cloud. Only numbers. What are the first numbers that you heard about? It was probably number 1, 7, 10. Little bit later, maybe you heard about 0. These numbers can be found anywhere in nature. This is why we are going to call them natural number. You have 1 house, you have 2 pencils, you have 3 apples, you have 4 t-shirts maybe in your garderobe. So these numbers can be found anywhere, and we are going to call them natural. And as we said earlier, you had this very terrible experience in primary school, but at the end you learn about negative numbers, and that's the most important. This set right here, it's what we are going to call the integers. In other words, the whole numbers. 0, 3, 5, -2, no fraction, and no strange things, okay? First very important remark is to understand that all natural numbers are also integers, but not all integers are natural numbers. For example, -2 is an integer, but it's not natural. But we must realize that every natural number is also an integer. Now, as you continued your math journey, you heard about very special kind of numbers, like fractions, decimals, some very, very strange numbers like pi, square root of 2. Why do I say that they are strange? It's because if I want to put it in the decimal forms, well, I will have to put an infinite amount of figure after the decimal points. So they are quite strange. Here, basically, we have what we call the real number. Again, all the numbers you have seen in primary school, the negative numbers also, they are all real. Every number that you have seen so far is what we call a real number. Okay, think about any number you want. I know it's a real number, but it may not be natural, it may not be a whole number, it may not be other sets that are here in between, but here it's not my point, so we are not going to see every possible set that exists, but there are many more sets. The point is to say, now you think about a number, I know it's a real number. In other words, if I had to draw what is called a number line, a real number line, which contains all the numbers that I put here, so this real line contains all the numbers you can think about, I don't know, integers, fraction, strange numbers, numbers, and so on and so on. Whatever the number you are thinking about, I know that I will be able to place it on this real number line. However, what I will not find on this real number line is the answer to this equation. Because as we said, there is no solution among the real number. So it's time to take a big step in your math journey and to extend this number system that was enough all along, but now it will not be sufficient. That's it, I extended the number system, and we are going to call this new very big set the complex numbers. And what I want you to realize directly is that every real number is also a complex number, but not all complex numbers are real, and this is what we are going to see now. So let's go back to this equation that is haunting us. We know that there is no real number that I can put there, but still, there is something I really want to write here. And maybe what you want to write so bad is square root of -3, except that you have always heard that you cannot do that, you cannot do that. But here, it's easy to realize that the square root we just cancel with the square, and that it should work. And you know what? That's it. That's it. That's the answer. The answer is square root of -3. We just have to break this mental barrier that has been put in our mind, saying that we cannot take, it's impossible, it's undefined. Well, starting from now, it's okay. By the time I'm recording this video, it's 2023, and I'm quite confident by saying that to you. But back in the 16th century, it was quite a huge controversy, actually. Why is that? It's because many strange things happen if we just let the existence of negative square roots. Like, we have very strange results, we lose this notion of ordering, so in the complex world you will see in the end of next video that we cannot say anymore that one number is greater than another in the complex world. So very strange things happen. But still, apparently, it was not such a bad idea to just let it be, since many centuries later, we are still talking about that. Also, you will see that the mathematical trick that is used to answer this equation, it's quite, let's say, disturbing. Here is the starting point of everything. I mean, of this extension of the number system. I will define I so that it is the solution of this equation. So yeah, it's exactly what happened, and maybe now you realize why it was such a controversy. Now imagine, tomorrow you have a math test, unfortunately you did not prepare, but you say, okay, Mr. the teacher, I defined x so that it is the solution of your question, and that's it. Okay, most probably the teacher will not appreciate, but then you can say, well, it's exactly what you did with complex numbers. We faced an equation without solution, and you said, okay, I defined y so that it is the solution of the equation. Okay, first of all, don't do that, or at least don't say my name. But most importantly, you understand that it took some time for other mathematicians to accept that, obviously. Okay, let's summarize what we have so far. We defined I so that it's the square root of -1. In the same way, we can say that I squared is -1. I is what is called the imaginary unit. It's like the starting point of this new world, which is called the imaginary world or the complex world that we will discover together. The main advantage of using y instead of square root of -1, as you heard, it's easier to write and way easier to say, at least for me. Also, it's to avoid confusion, and I will show you a very important example about that in the end of this video. Let's go for 3 important remarks to close this intro. The first one is quite important actually. It's a huge misconception to say that complex numbers does not exist. They are used in a lot of domains, they are very useful, they exist just as any numbers exist. And I wanted to show you this quote from Carl Friedrich Gauss, a very, very famous German mathematician. You can pause and read the quote if you want, but the point is to say that complex numbers are very badly named. They have a terrible name that really does not reflect the importance, the reality of this extension of the number system. The word imaginary number suggests that they do not exist, and in fact they was named like that to make fun of this kind of number, because as I told you, in the 16th centuries there was a lot of controversy, but unfortunately we got stuck with this name and really just realized that it might be impressive to work with something called complex number, with something called imaginary number, but really the name does not at all reflect the subject. Why do I insist on that? Because before you I learned about complex number, and really when there is the word complex in the subject that you want to study, it's understandable that you might not have a good feeling about this, but really don't mind this terrible name. And by the way, he suggested instead the word lateral units. That makes much more sense, and you will understand why in the next video. Second remark is to say that complex numbers are useful. Okay, even though they are called complex and imaginary, they are real, they exist, and they are very useful. As I told you in the beginning of this video, without them you would not be able to watch my video. So thank you for that. And why is that complex numbers are so widely used in electronics? Of course we will go back to that. But let's say that complex numbers have something called a modulus. It's a kind of a length, an amplitude, you can see many different ways. They also have an angle that is also called an argument, a shift. And in electronics, we talk a lot about signals that have also amplitude and what we can call shift, like it's kind of the angle. So it's very useful in electronics to represent signals with complex numbers. But you will understand it more in depth in future videos. Another application of complex numbers is simply solving equations and problems. And here I really wanted to show you this example in particular. This equation right here has 3 real solutions. Okay, if you want, you can open GeoGebra, show this function. Also, you can draw a line at y is equal to 1, and you will see that there will be 3 intersections. But if you want to apply the formula to find the solutions, by the way, this is a third degree equation, so the formula is way more complicated than just, b squared minus 4ac, the formula that you know by heart. Here it's a little bit more complicated, but still there is a formula that can solve that. But it happened that during this formula, you will have to shift to the complex world, and then you will go back to the real world. In other words, without the complex numbers, we will not be able to solve this equation using the formula, even though there is 3 real solutions to that. And it happens often that you will have to shift to the complex world and then go back to the real world. So it's important to learn some theory about the complex world. This one, we will come back to that, but complex multiplication has a lot to do with rotation, but we'll come back to that. Finally, just to tell you that there will be a lot of trigonometry in this series of videos. Of course, I will do a lot of reminder when I can, but just I would say that you have to know some basic trig functions and you have to know some basics about the unit circle. Having said that, I think now you deserve to see the bonus. What if I tell you that I can prove that minus 1 is equal to 1? Of course, minus 1 is not equal to 1. There is somewhere here a problem. What I did is that I used this formula. This is a well-known formula, and you have used it so far, and so far it worked every time. Here, obviously, something went wrong, and I challenge you to find what went wrong, and we will discuss it during the problem-solving session. I just wanted to show you this to say that it's not that natural to accept the existence of negative square roots. It leads to strange results and things like that, so that's not surprising that it caused many controversy back then. And also to show you why using I instead of square root of minus 1 may be a good idea to avoid this kind of situation. Thanks for watching and see you in the next video.